So our first speaker uh, is who will be providing our keynote address on the most promising innovative technologies. His name is Vivek Prasad. He's the senior analyst and program head of SATCOMs for Analysis Mason. It used to be NSR and they merged together. And they have also, NSR in the past have spoken in this conference. So he will give us the keynote on most promising innovative satellite technologies. Vivek?
Thank you, Virgil. I'm happy to be here. So I'll be presenting few slides on the most promising satellite and SATCOM technologies. Next slide, please. Yeah, so if we look at the last 4 to 5 years of the satellite and SATCOM industry, the industry is transforming at an unprecedented pace. And all of these transformations are led by multiple innovations at different levels of the value chain. Starting with manufacturing, most certainly the philosophy change from system level redundancy to satellite level redundancy, utilization of commercial off the shelf components, system level standardization and modularization has led to most efficient serial production that reduces the lead time and the overall cost. Increasing number of manufacturing of flexible satellites in order to optimize the operational efficiency and asset utilization. So these has been some of the key technologies which had led to the improvement of space industry and eventually SATCOM industry manufacturing value chain. Coming to the launch vehicle side, clearly reusable launch vehicle has made access to space significantly affordable and has reduced the overall cost for the satellite operators. Looking at the type of satellites, video market, as we all know, has been declining at around 3 to 5% annually, and network market is the future opportunity, and hence we are seeing a clear transition from usage of wide beam satellite to spot beam based high throughput and high density satellites. Further to that, software defined satellites are also significantly coming into the picture in order to align upstream supply with the downstream demand as the time progresses. Constellations within the types of satellite has been, as we all know, a key focus of this transformation, especially at the moment with Starlink and moving forward with other players such as Kuiper, OneWeb, etc. On the equipment terminal side, the key technologies, FPA is one of the core technology which is enabling deployment of non-geo services, especially the affordable FPAs. Multi-orbit terminals are again another key technology which is enabling integration of benefits of different assets in different orbits such as LEO, MEO, and GEO. The next, on the terminal side, the next key technology which we see will have a larger impact in coming years are laser-based inter-satellite links. As more and more constellations are deployed and the supply is coming from there, more network optimization has to happen, and laser ISLs will play a major role in this aspect. On the application side, some of the key application which is already having the impact, such as SD-WAN and cloud, we are seeing increased utilization, not only at the operator or internal use cases, but also at the customer end use cases as well. 5G is integrating SATCOM capabilities with telco capabilities, and hence the demand is expected to grow for the SATCOM players with increased usage of 5G. Last but not the least, artificial intelligence is the future, and there are various layers of artificial intelligence that can be utilized or implemented to improve or to impact the overall SATCOM industry in the ever-changing and this competitive industry landscape. So all of these technology as an unified way, we see what is the core focus. There are two key core focus. One is increasing bandwidth or the supply, and reducing the overall cost across different layers of the value chain, so that eventually at the service level the cost is optimized, and it unlocks a larger addressable market across different use cases. Next slide, please. Yeah, so as we said that non-geo has been at the core focus. So the first slide is on non-geo. If we look at the supply trend, so Starlink has 6,000 plus satellites in orbit, and on at the level of pricing, currently they have evolved as one of the largest player in the consumer broadband market, with just 2 to 3 years of operations in the segment, and now they are expanding into other verticals, especially mobility at the moment. One of the key trend which we see is they are undercutting geo incumbents pricing by around 4 to 7 times. And as more surge comes from in terms of supply, it comes from players such as Kuiper, Lightspeed, and OneWeb Generation 2. We expect that the capacity, SATCOM capacity, is going to be increasingly commoditized. Overall, if we see by the end of the ongoing decade, around 90 to 95% of the total capacity supply will come from the non-geo market. Again, this is not the usable capacity, but this is the overall aggregated capacity. Next slide, please. The next key technology is flat panel antenna, because flat panel antenna a few years back were considered as one of the key bottleneck for the non-geo services because of its cost, because of the complexity. But with in the last 4 to 5 years, the innovation, the design changes, and because of economy of scale, we have seen significant drop in terms of manufacturing cost for the flat panel antennas. At the moment, we are seeing prices somewhere around $500 to $600 per unit, especially for the consumer broadband use cases. So moving forward, how we see in terms of number of shipments or number of terminals, most of the terminals will be manufactured by non-geo or LEO players. And by the end of the year, the cost will uh, reduce to closer to $300 per unit. And this is for the price sensitive use case or the application that is consumer broadband. For other applications such as enterprises, mobility, etc., it will be higher than uh, uh, $300 per unit price. But in terms of revenue contribution, if we see, we still feel that premium geo mobility terminals will drive revenue growth within the flat panel antenna opportunities, and majority of this growth and demand will come from government and military applications. Next slide, please. The next key technology, again, this is also linked with the non-geo constellations. At the moment, if we look at the non-geo constellation, without inter-satellite links, they need a large network of ground segment or the gateways geographically distributed across the Earth. But with inter-satellite link, we expect that the network will get optimized with fewer gateways or ground stations on Earth. So overall, the laser communication terminals, we see that 98% will be used for the inter-satellite links, and especially by the constellation players such as Starlink. Overall, around 8,000 terminals are going to be launched in this ongoing decade, and most will be, as I said, most will be used for space-to-space communication and further improving the network efficiencies of the non-geo constellations. Only 2% we expect are going to be used from space-to-ground applications moving forward. Next slide, please. Yeah, so the previous three slides were non-geocentric because they have been a key focus, and they have been the key reason for the industry transformation for the last 4 to 5 years. But geo operators, coming to the geo operators, they need to counter the competition or the transforming landscape which is happening at the moment within the SATCOM ecosystem. They need to counter all of these competition. They need to achieve the price efficiencies. They need to align their in-orbit asset more accurately with respect to the changing downstream landscapes. So one of the key technologies which we see is going to have a larger impact in this ongoing decade is software-defined satellites. So more and more high density and high throughput satellites with software-defined flexibilities are going to be the key in order to improve the cost. Again, with standardization of software-defined satellite platforms, we expect the manufacturing cost per Mbps to reduce in coming years. And also because of the competitive pressure from non-geo operators, these prices per Mbps will come down. And if we look at the ongoing decade, we expect around 89% of the total communication satellite will have either flexible and fully, or will have either partial or fully flexible capabilities, aggregating to a cumulative opportunity of around $54 billion across spread across the decade. Next slide, please. Yeah, so this is the last technology, and clearly artificial intelligence, as we all know, that it is impacting nearly almost all industries, and everyone is looking towards it uh, to reap its benefits and its capabilities. And SATCOM is also going to be one of the industry, considering the ecosystem is becoming extremely competitive, and the optimization investments and optimization direction has to gain its pace, especially for geo players. And if we look at some of the solutions which is already existing and has been developed is Amazon Forecast. It is a capacity time series forecasting, and it helps operator plan uh, change in bandwidth demand across the day, across the season, across different wide range of users. Uh, for example, consumer broadband, enterprise VSAT, mobility, etc. So we expect that artificial intelligence in SATCOM will be utilized both for internal processes as well as at the customer facing. In looking at the different timelines, we expect that we are at the moment exploration or the trials phase where AI use cases are in very early stages within the satellite industry. Currently, mostly it is being used for Earth observation application, and uh, operators are looking for its benefit or its integration in order to improve their internal processes and networks. Phase two will be an expansion phase. It will be somewhere around 2028 to 2030, where artificial intelligence will be applied across some SATCOM applications, and we expect that enterprise VSAT is going to be one of the first application which will adopt AI into their network. And in phase two, as we said, that more customer facing will initialize uh, in 2028 and 2030. Phase three is going to be the deployment phase, which is beyond 2030, where AI will be deployed in most space and satellite segments, and it will be used for both internal and client use cases. So we see these technologies uh, to be going to impact the overall satellite and satcom industry in coming years, and some of them which are presented here are already impacting the industry at the moment. Next slide, please. Thank you. So this is the end of my presentation. I'm happy to answer if there is any question.
Well, thank you, Vivek. That was a really, really very interesting presentation. Almost like a roller coaster ride of so many different new things, and it really never ceases to amaze me. I've been in the industry over 20 years, and it's still innovating. You know, it's still coming up with all these new ones. For those of you who've just joined us and those who are already with us, you have a chat button there if you have a question. I don't see any questions yet, but let me just ask you, Vivek, while see if we have any questions coming. Of all the technologies that you've listed, and there's quite many, software-defined satellites, flat panel antennas, etc. What are you most bullish of? And when I mean by that is, what do you think has the most potential economically, or to take off?
Yeah, so at the moment, in the next 3 to 5 years, what I see is inter-satellite links.
Hmm.
This is already the non-geo players are accelerating across different use cases, such
Hmm.
as I mentioned, in consumer broadband, enterprise, etc.
Hmm.
With the deployment or with the inclusion of inter-satellite links on board, with fewer number of gateways, they will achieve further improved cost efficiencies. So at the moment, they have addressed the manufacturing level cost efficiency, launch level, uh, customer premise equipment level, and at the network level. So within the space, at the ground station level, there is a gap, and that gap is going to be addressed by inter-satellite link, and that will further increase the competitive pressures which we are seeing in the industry at the moment. In addition to the new players coming, uh, especially from the
Would
non-geo
that help
segment.
geos be more competitive with the intersatellite links with the non-geostationary satellites?
Yeah, there is a possibility. So most players are looking multi-orbit now. So they
Mhm.
want to utilize the benefit of geo and non-geo. So and if we see the type of consolidations which has happened in the industry, such as Eutelsat OneWeb or different levels of partnership with OneWeb or Starlink. So we see, or O3B and SES, we see that multi-orbit uh, is going to gain some momentum in coming years.
Mhm.
And if there is internal satellite link out there, at the moment we see that most of this inter-satellite link will happen across LEO satellites,
Mhm.
but they have to interact different orbit satellites in order to achieve better services and better solutions. So there is a possibility, yes, with inter-satellite links, even the incumbents with partnership uh, of LEO players, uh, they can also achieve significant or sustainable growth.
Right, right. Well, if there are no more questions from our audience, any final thoughts, Vivek? How do you see the future? Are you generally bullish? And, do you think, there's thought about geos? Will they survive all these LEOs?
Yeah, so this is a very good question, and all geo players are considering and understand the challenges which is ongoing and upcoming, and they are building and developing their strategies. One key recommendation that I'll give to the geo player is compare the cost efficiencies across different segments of the value chain, and in order to remain competitive in a market segment, you have to achieve a similar level of cost offerings and bandwidth offerings, especially especially in the markets such as enterprise VSAT, mobility, etc. Because the non-geo services are uh, increasingly gaining momentum in these segments now.
We have a question from our audience. I think she's from your country person. Raushan Jha asked that,
Mhm.
is AI a game changer? And I was about to ask that actually. AI, is it a double-edged sword? Is it still in infancy? Is it ready for prime time?
Yeah, it is very early to tell this, but it
Hmm.
could possibly be a game changer because uh, we see that if we see the data usage profile of different end users, such as
Hmm.
enterprise VSAT within the mobility, aero, maritime, land mobile. So SATCOM addresses wide range of use cases, and for every use case, the data usage profiles are different, and it changes throughout the day.
Hmm.
So, can all of these data be integrated, and can satellite take its own call with flexible satellite to deploy bandwidth and to uh, move their powers and beams across a region to achieve the best possible cost efficiencies. So if that happens, it can be a certain game changer.
Well, unfortunately, we've run out of time. I know there's some more questions about the direct to phone, etc. We'll have that Vivek address that maybe offline by email or something, and also the other sessions we'll actually be continuing that. So, well, thank you very much, Vivek, for your enlightening insights on this very important topic, which really helps us now go through the